So this will be the first lecture over alcohols and thiols, chapter 10. So in this lecture, we'll look at how to name alcohols and thiols and look at how to remind you how to classify them. So if you remember, what is an alcohol? So any molecule that's got an OH group attached to an alkyl group would be an alcohol. So of course there's an OH in this functional group, but that's not an alcohol, right? If it's attached to a C double bond O, that's a carboxylic acid. And the thiol is any molecule that's got an SH attached to an alkyl group would be a thiol. So we've looked at how to classify them before, but let's go through some more examples to remind you. So the alcohol is attached to that carbon, and then you count how many carbons is attached to that one, right? So there's one carbon attached to the carbon with the OH, so this will be primary. In this case, there's two carbons attached to the carbon with the OH, so that would be secondary. Here, there's three carbons attached to the carbon with the OH, so that would be tertiary. Here, there's one carbon attached to the carbon with the OH, and the carbon that the OH is on is a double bond, so this is primary and vinyl. Here, it's one carbon away from a double bond, so that's allylic, and there's two carbons attached to the carbon with the OH, so that's secondary and allylic. Here it's directly attached to a benzene ring, so it's aryl, and all aryl halides or alcohols would be secondary, so that's a given. In this case, it's one carbon away from a benzene ring, so that would be benzylic. And there's two carbons attached to the carbon with the OH, so it's secondary also. And in this one, there's no carbons attached to that carbon with the OH, so that would be methyl. So hopefully you have this by now, but you can take just a minute to practice if you wanted to pause the video. So take these 5 alcohols and classify them. Okay, so for this first one, you should have came up with, so that carbon with the OH has one carbon attached, so it's primary. This alcohol is secondary, not allylic because it's too far away. This one has 3 carbons attached to it, so it's tertiary, and it's allylic, and it's benzylic, right? Since it's both next to a carbon-carbon double bond and a benzene ring. This one would be secondary. And so alcohols, I find lots of importance of alcohols in biological chemistry. So this will be one example. So here's your alcohol, and that OH, that alcohol carbon has 2 carbons attached to it, so cholesterol is a secondary alcohol. Of course, it's got an alkene in it as well, so it's an alcohol and an alkene in functional class. Okay, so if we look at how to name alcohols and thiols. So for the alcohol, you change the parent ending to OL, which you see here in the name of cholesterol. The OL tells you it's an alcohol. And for thiol, you just add OH, you would just add thiol to the end of the parent name. And so also we'll see in these examples, when you number the parent chain, you always keep the numbering scheme, you keep the highest priority functional group numbered as low as possible in the name, irregardless if that's the lowest numbering scheme or not. So this is a rule that trumps other rules. The highest priority functional group has to have the lowest number as possible. Okay, so if we name these alcohols, so 1, 2 carbons would be ethane. So change the E ending to OL. So this would be ethanol. Oops. In this case, 1, 2, 3, so that would be propane. Change the E to OL. So propanol. But that's not good enough in this case because you do need to specify where the OH is at. We didn't have to in ethanol because it has to be on, there's only 2 carbons, right? So it has to be on carbon 1. But in propanol, it could be on carbon 1, or the OH could be on carbon 2 like it is in the next example. So we need to indicate where the OH is at. So this would be propan -1 all. So you put the 1 right before the letters in the name that tells you what it is. And so this would be propan 2-ol. Okay, so for this one, 1, 2, 3, 4. So this would be 3-methyl butan 1-ol. Okay, so in this next molecule, there's two functional groups. There's an alkene and there's an alcohol. And so now you need to know the list of priorities, what has more priority in terms of functional class. And usually was basically based on the more oxygens in the functional group, the higher the priority of the functional group. So carboxylic acids would have the most priority because you can think about like 3 oxygens because the double bond counts for 2. Aldehydes, ketones, 2 oxygens. Alcohols, 1 oxygen. And then alkenes have priority over alkynes, and then your alkyl halides basically have very little priority at all. So the alcohol has higher priority than the alkene, so we need to number the carbon chain to keep the alcohol as low as possible, which means 1, 2, 3, 4, 5, 6. If we number from the right, the alcohol is at carbon number 3. And if we numbered from the left, it would be at number 4. So we need to go with the number 3. So we need to number from the right. So this would be 6 carbons, so that would be hexane. To take care of the alcohol, change the E to OL. To take care of the alkene, change the A to E. And then put a number before each of those letters to indicate where it's at. So this would be hex. The double bond starts at carbon number 5, so 5N, and then the OH is at carbon 3, so 3-ol. So that would be hex 5N3-ol. Okay, so if we have a ring, so where do you start numbering from? 1, 2, 3, is it like that? Or is it 1, 2, 3? So 1, 3 either way, but the alcohol has higher priority, so you got to keep the alcohol as low as possible. So this is going to be number 1. So we have 3-bromo, and then cyclohexane and ol. So you don't have to put a 1 in front of the ol because by default that has to be carbon number 1. And of course there's one thing missing. What else is missing from the name is you got to take care of the stereochemistry. They're both on a solid wedge, so they're cis to each other. And that comes at the front of the name, so cis-3-bromo cyclohexanol. And then of course, let's see. Oh, sorry. So that's actually not quite good enough for the name. And the reason is because this is also cis-3-bromo cyclohexanol. But those two molecules are not the same. Why are they not the same? Because there's a chiral carbon, right? That's a chiral carbon, and that's a chiral carbon. So if we want to be more specific with the name, we would need to include stereochemistry RNS. So for the carbon with the OH, that's priority 1. Let's use a different color. So we'll put it in pink. So that's number 1. Going this way is number 2, and that's number 3. So 1 to 2 to 3 is clockwise, 4 is in the back, so the arrow stays clockwise, so this is R. And then for the carbon with the bromine, that's number 1. The pathway with the OH is number 2, and that's number 3. So that's 1 to 2 to 3 counterclockwise, so that would be S, and the lowest group is in the back, so it stays S. So this would be 1R, 3S, 3-bromo, cyclohexanol would be a better way to name that because that clearly differentiates between the other cis isomer. So what would be the name of this one? It would be the enantiomer, so it would be 1S, 3R, 3-bromo, cyclohexanol. Okay, so if we were to name this, so there's no chiral carbons here, but there is cis and trans here, right? So here the OH is on top of the hydrogen, and the tert-butyl is on top of the hydrogen, so this is a cis isomer. So this would be 1, 2, 3, 4. So that would be 4 tert-butyl. cyclohexanol, and this is the cis isomer. So that would be the name. Okay, so 1, 2, 3, 4. So this is cis or trans. So this is on bottom of the hydrogen. This is on top of the hydrogen. So this is a trans isomer. So trans. And then 4-chloro. So cyclohexane. So you change that to OL for the alcohol and that to E for the alkene. And the alkene starts at carbon number 2. So cyclohex 2N O would be the name of that molecule. And again, you didn't need the 1 for the OH because it's understood that it's at carbon number 1, since in that molecule the OH has the highest priority functional group, so it's understood that that's where you started numbering at for number 1. So technically you could also include stereochemistry of the alkene, but again, that's typically not done in ring compounds because it's just understood what they look like, because of the geometrical constraints of having a double bond in a small ring. Okay, so for this molecule, 2, 3, 4, 5, 6, 7, 8. So that's not a tert butyl at number 6, right? Because carbon 7 and carbon 8 is part of the parent. Okay, so now we have an alkene where we need to do cis and trans. So if we split the double bond in half, this is priority 1 and 2, and 1 and 2. So that's an E alkene. And in terms of the chiral carbon, so that's priority 1, 2, and 3. 1 to 2, 3 is clockwise, but 4 is on the solid wedge, so we have to flip the arrow, so that's counterclockwise. So this would be 2s, and to take care of the chiral center, and 5e to take care of the stereochemistry around the double bond. And then we have a 7,7 dimethyl. All right, so 2 methyl groups here at carbon number 7. And then 8 carbons would be octane. The carbon double bond, so octane. That would become E for the double bond, and that become OL for the alcohol. So oct double bond starts at carbon number 5, so 5N. And OH is at carbon number 2, so 2OL would be the name of that molecule. Okay, so if you have an alcohol attached to benzene ring, that molecule is called phenol. So that's just a molecule to memorize. Okay, so this example, just to illustrate that, so even though you have a 6-carbon ring here, so 6 carbons is longer than 3 carbons, but the OH has to be in the parent. So that means this has to be the parent, the 3-carbon chain. So you always keep the highest priority functional group as part of the parent. Okay, so then the cyclohexane becomes a substituent. And since it's a substituent, the A and E ending is changed to YL, so that's a cyclohexyl. So this would be 1 cyclohexyl, and then propane would become propanol. But you need to indicate that the OH is at carbon number 1. So 1 cyclohexyl, propan, 1-ol would be the name. And here, so you have a phenol, and that's carbon 1, 2, 3. So this would be 3-fluoro phenol. Okay, so what if you have 2 OHs or 3 OHs in the molecule? So that would be propane. So just like if you had 2 methyls, it would be dimethyl, or 3 methyls would be trimethyl. If you have 2 OHs, so OH would be ol, so this would be diol. And to make this easier to say, you keep the A, and so 1, 2, diol. Otherwise, you have 2 consonants next to each other. If you change the E, right, then you would have N next to D, and that's harder to say. So to make this easier to pronounce, you keep the A if you have more than 1 OH, and then just use di, tri, tetra to indicate how many OHs there are. Okay, so in this case, 1, 2, 3, 4, 5, 6, so cyclohexane. And again, instead of changing that to OL, we're going to keep it and then just indicate where the OHs are at. So 1, 3, 5, and then triol. So cyclohexane 1,3,5 triol would be its name. Okay, so if you have thiols, how do you name thiols? So it's easy. Just take the parent butane and stick thiol at the end. But you have to indicate where the thiol SH is at. So that would be butane 1 thiol. And in this case, so this would be 1 bromo, and now butane 2 thiol. And of course that's a chiral carbon that the thiol is at, so you need to indicate stereochemistry. So the SH is number 1, that carbon is number 2 with the bromine, and that's 3. 1 to 2 to 3 is counterclockwise, that would be S. 4 is in the dash, so the arrow stays S. So this would be S, 1 bromo butane 2 thiol. You can say 2S, but you don't need to say 2S because it's understood that there's only 1 chiral carbon in that molecule, so S must belong to carbon number 2. Okay, so this molecule, 1, 2, 3, 4, 5. So you have an alkene that has cis and trans possibilities, so that's priority 1 and 2, and that's 1 because chlorine beats carbon, right? So you go in order. You don't come to the SH until you've already established priority, so the SH doesn't matter in terms of establishing priority here because you're just comparing a chlorine to a carbon. So the ones are opposite, so this would be an E alkene or a trans alkene. So let's see, so we have E or trans, doesn't matter. 3 chloral, 4 fluoro, and 5 carbons would be pentane. So we'll change that A to E for the alkene, and then we'll just stick thiol at the end. So pent 3N 3ene 1 thiol. I think I did that right. 1, 2, 3, I think that's right. Okay, so now we have 2 functional groups in the molecule again, SH and OH. So which has priority? The alcohol does. So if thiol does not have priority, then it's called mercapto. So if you name thiol as a substituent, you call it mercapto. So this would be 1, 2, 3. So this would be 3 mercapto. Propan 1 ol. Sorry, let's try that again. Three mercapto propan 1 ol. Okay, and so lastly in this lecture, so one important physical property of thiols, so thiols are also called mercaptans, is that they absolutely stink. So as an example, so this molecule is ethane thiol. So that's a molecule that's added to natural gas. Why is it added to natural gas? Because natural gas it's odorless. And so it's pretty important to know if there's a leak because it's a flammable. Natural gas obviously is flammable. And so ethane thiol is added to natural gas so that one can detect a leak. Because humans are very sensitive to the odor of a thiol. For ethane thiol, for example, it can be detected by humans at 1 part per billion concentration. So that would be meaning 1 ethane thiol molecule in 1 billion air molecules, humans could detect that. It's how bad they stink. Okay, so that's it for this lecture. So we'll stop there.